This module on full mesh, hubs, and spokes provides an overview of the WAN topologies and their functions. At the end of this module, you'll be able to describe full mesh topologies and describe the hub and spoke topologies. Versa supports SD-WAN topologies such as full mesh, partial mesh, hub and spoke, and combinations of these topologies. Versa Control Plane provides flexibility to define and establish the topology of choice on any tenant. On devices that have multiple VRFs for the same tenant, each VRF can be part of a different topology if desired. Versa's industry-leading SD-WAN solution supports the propagation of routes to multicast source subnets with multi-protocol BGP. This allows the VPN topology for multicast to be different than the unicast topology. For example, the multicast topology can be hub and spoke, whereas the unicast topology can be full mesh. The first topology we will discuss is the full mesh topology. Full mesh is defined as any-to-any connectivity, where every edge device has a tunnel to every other edge device, and each device can forward traffic directly to any other CPE within the SD-WAN. Note that full mesh is shown from the branch N perspective, and that all devices will create a full mesh of tunnels to all other devices. Let's look at an example to help understand a full mesh topology. In the diagram, CPE1 is connected to LAN A. Through BGP routing policy, which is automatically created by Versa Director, CPE1 advertises reachability to LAN A to the Versa controller. As a route reflector, the Versa controller advertises that reachability information to all other CPEs in the routing domain. Because the devices are configured as full mesh devices, all other CPE devices are pre-configured with a BGP policy that identifies and accepts the routes from all CPEs. Once the route is accepted into the local routing table of a remote CPE, a dynamic secure tunnel is created to the advertising device, which allows direct forwarding of secure SD-WAN traffic from any CPE device to CPE1 and LAN A. Full mesh topologies provide point-to-point reachability between all devices. The configuration for full mesh SD-WAN is simple, and the Versa Network solution provides scalability of up to 2,500 tested site-to-site IPsec tunnels. A major consideration when deploying a full mesh environment is the SLA probes that are sent between devices to validate transport paths. SLA probes are bidirectional and require responses. In addition, it's common for probes to be sent in multiple forwarding classes to validate traffic profile requirements. In Versa networks, probes are sent in the network control and expedited forwarding classes by default. Because of the potential overhead of sending so many SLA probes across the SD-WAN, Versa Networks has integrated features that suppress SLA probes between sites that are not actively communicating. This feature greatly reduces the amount of SLA probe traffic across the network, while maintaining link status and performance monitoring throughout the SD-WAN domain. Next, we'll discuss hub and spoke topologies. The goal of a hub and spoke environment is to direct all data plane traffic through a centralized site, device, or set of devices, and to prevent spoke-to-spoke tunnels and direct communication. There are two things to consider when creating a hub and spoke environment. First is the management of tunnel creation between sites, and second is the advertisement of LAN networks and the forwarding path to reach those LAN networks. There are various hub and spoke topologies, such as spoke-to-hub only, spoke-to-spoke via hub, and spoke-to-spoke direct. Click each option to learn more. Next, we will look at the various deployment options in detail, starting with spoke-to-hub only. In the example, LAN A is reachable through CPE1. CPE1 advertises reachability to LAN A to the Versa controller, which re-advertises the LAN A prefix to all CPE devices and the hub. Because the CPE devices have been configured as spokes in a spoke-to-hub only topology, they discard the route as it arrives. The hub, however, is configured to accept all of the routes from remote CPEs and installs the routes in its routing table. The hub advertises its LAN routes to the spokes. Because the routes from the hub LAN are marked differently than the routes from the spokes accept the hub-sourced LAN routes and install routing and forwarding information to the hub-connected resources. Another option is to create a static default route on each CPE device that directs all traffic, both SD-WAN and non-SD-WAN traffic, towards the hub. With this topology, all traffic that arrives at a CPE is forwarded to the hub site, regardless of whether or not the remote destination is reachable, since the forwarding action is performed based on a statically configured next hop. The potential drawback to this design is that WAN link bandwidth can be utilized for non-reachable destinations, because only the hub site has full reachability information. With spoke-to-spoke via hub, a similar process occurs as with our previous hub-and-spoke example. Each device in the SD-WAN is configured with a routing policy that rejects routes advertised by remote CPEs. However, with this topology, the hub site is configured to accept routes received from remote CPEs and to re-advertise the routes back to the Versa controller with itself labeled as the source of the routes. Although the CPEs in the domain are configured to reject routes advertised by remote CPEs, they are also configured with a policy that accepts routes advertised from the hub site. With this implementation, all sites have reachability information to remote sites through BGP advertisements from the hub, and not through a locally configured static route. The hub is still marked as the next hop for all SD-WAN traffic, so all traffic flows through the hub. This allows reachability information to be advertised dynamically through the SD-WAN, so that CPE devices only send traffic over the WAN links and utilize bandwidth for known reachable destinations within the WAN. This spoke-to-spoke via hub process is a standard and common method of route management used by service providers globally to provide spoke-to-spoke via hub connectivity to customers with Layer 3 MPLS services, and is a proven and scalable process. Next, we'll look at spoke-to-spoke direct or regional hub-and-spoke. In this example, multiple hub-and-spoke topologies are deployed, which are linked by hubs. Within a spoke group, full mesh connectivity is established between CPE devices. The hubs of each spoke group serve as gateways to reach other spoke groups. This allows segmentation of a domain into different regional or functional spoke groups. The spokes advertise their node information and LAN routes to other devices in the SD-WAN through the controller, as with other topologies. The key difference is the addition of a BGP community tag that is used to determine to which mesh group a spoke belongs. Received routes that contain the same mesh group community are accepted by the spoke, and direct tunnels are formed between the devices. Routes that do not contain the locally configured mesh group community are rejected. All routes from the hub are accepted, which allows LANs in other mesh groups to be reachable through the hub. The route advertisement path through the SD-WAN is from the CPE devices to the controller, and then back to the CPE devices. Inside the Versa controller, all routes received from CPE devices are installed in a tenant-specific routing table in the tenant control VR. The controller then reflects or re-advertises those routes back to all connected clients. In a multi-tenant environment, a separate control VR is created and managed for each tenant. Routes for each tenant are maintained separately, and BGP policies are unique and separate for each tenant. Within each CPE device, multiple virtual routers are created to manage routing and forwarding functions. Each transport interface exists within its own virtual router, as does each customer LAN interface. Between the transport and LAN VR sits a tenant control VR, which is where the tenant routing information is stored. SD-WAN devices advertise BGP routes over the secure management tunnel between the devices. The secure tunnels terminate within the control VRs at each end of the tunnel, and therefore the routes are placed within the control VR. Once a route arrives in the tenant control VR, routing policy moves the tenant routes into the tenant LAN VR, where they can be used for LAN routing, and where they can be redistributed into the local LAN if desired. With multi-tenant devices, a separate set of tenant control VRs and LAN VRs is created for each tenant. The transport VRs are shared among all tenants on the local device. Traffic that is forwarded across the transport interfaces through the transport VRs is already encapsulated and marked appropriately for each tenant by the tenant control VR prior to being forwarded through the transit hop. With a hub-and-spoke topology, a method needs to be put in place to regulate which routes are accepted by the CPE devices. In order to make the routes appear to have been generated by the hub, a new set of virtual routers is implemented in the hub device. When a hub device receives routes from remote CPEs, the routes are installed in a tenant LAN VR locally. A new VRF is added to the hub device, which is called the Tenant LAN VR Export Routing Instance. When routes are received from remote CPEs and placed in the Tenant LAN VR, routing policy is used to move these routes from the Tenant LAN VR to the Tenant LAN VR Export Routing Instance. From that routing instance, they are redistributed back into the Tenant Control VR as new routes within origin of the hub device. This process essentially recreates all routes within the SD-WAN on the hub device and makes the hub device the origin of the routes. When the routes are redistributed back into the Tenant Control VR, they are marked with a hub-specific community tag the remote CPE devices are allowed to accept into their local routing tables. This process is a well-known, well-proven, and standard VPN process used by service providers globally for MPLS-based VPN services. You have reached the end of this module. In this module, you learned that Versa supports SD-WAN topologies such as full mesh, partial mesh, hub and spoke, and combinations of these topologies. Full mesh is defined as any-to-any connectivity, where every edge device has a tunnel to every other edge device, and each device can forward traffic directly to any other CPE within the SD-WAN. The goal of the hub-and-spoke environment is to direct all data plane traffic through a centralized site, device, or set of devices, and to prevent spoke-to-spoke tunnels and direct communication. There are various deployment options in the hub-and-spoke topology, such as spoke-to-hub only, spoke-to-spoke via hub, and spoke-to-spoke direct or regional hub-and-spoke.